Hello guys, Jim Hannon, Golden Stars. This is a process image from the other night, well actually last night, of NGC7331. It came out okay, but not as well as I had expected or hoped. The main problem was not getting enough data to fill in the arms of the galaxy, which you can see down in here. The arms extend down. There's a nice little dust lane that comes through here, as you can see. And in this part up in here, you can see there's an arm that comes up and around. Now, if I had continued the exposure and could have gone into the hours long, it would have brought this out much better. This is only a total of 3 hours and 5 minutes of data, most of it in luminous, which is just plain white light. And then I only got around anywhere between 32 to 40 minutes in red, green, and blue. And therein lies the problem. I didn't get enough data to really work with on it. I am happy. I mean, the image is not that bad. And again, there's these galaxies I talked about. There's one that's deep in the background. There's a nice one here. That one's way off in the background. And let's see, where else are we? There's one here. There are other fainter ones, like down here. There's a real faint one. This is actually in the galaxy field, and not too far away. I believe it would be off in this direction here, down here. There's a group called Seaford Galaxy, not Seaford Galaxies, but a group of galaxies. In fact, if you're familiar with the movie It's a Wonderful Life, and they show these galaxies talking to each other, that's the group of galaxies they used in the movie. The name of that group is Stephan's Quartet of Galaxies. Now, when I tell you that this galaxy is 70 to 75 million light years away, how do you know that I'm telling you anything that's nearly the truth? Well, when I give some lectures on astronomy, what I do is I start with our solar system and explain very briefly how we learn the distances within our solar system, and then that expanded into the distance to the nearest stars, which was simply done by finding stars that were near enough where if you observed it on, say, June 1st and then on January 1st on either side of the sun, and you had a star close enough, you can get an angle that you measure. And it was simple trigonometry. Back it was simple when I used to know how to do it. Couldn't do it now, though. You could calculate the distance to that nearby star. All right, that's fine for nearby stars, but when we start getting out into millions of light years, we have to use a totally different way. The Andromeda Galaxy, 2.5 million light years away, we can use variable stars, which are called Cepheid variables. Carl Hubble of the Hubble Space Telescope and Henry and Leavitt were the ones that really came up with that information. They showed that these stars changed at a regular pace according to their brightness. And so once we identified these stars in the Andromeda Galaxy and we could see how bright they were compared to if they were close by, we could determine how far away they were to be that dim. Now, the way we determine distances to these long distance galaxies is by what are called type 1A supernovae. These are stars that explode. They're binaries where they are very massive. Primary is pulling material off of a secondary star. So much material builds up on the primary that it actually causes that star to explode. And they explode with a very regular brightness. So we can use them as what they're called standard candles. And the way this works is, just think if you had two 100-watt light bulbs on bases, and you were in a football field and you were standing on an end zone line, and put those two lights at 10 yards away. They would look exactly the same distance. Now take one of those 100-watt light bulbs, walk it all the way down to the other end zone, then come back and look at the one at the 10-yard line compared to the one down at the other end at the end zone. Which one's going to look brighter? Naturally, the one just 10 yards away. The one down at the other end of the field is going to appear much dimmer. So that's basically the idea of how a standard candle works, and that's how we determine these distances of the galaxies, we and the astronomical community. Again, not a bad image. I would really like to extend the exposure time much longer. I may in another night get out there and spend at least another 3 or 4 hours adding color data to these arms and try to get some more detail there. Try to pull a little more detail out of that dust lane that's right here. And also maybe add some hydrogen alpha light, maybe several hours of that. And what that does is if there's any really hot star forming regions in these arms, they'll show up as bright pink areas. But anyway, that's the image that I attained from all that work last night. Totally spent probably about 6 hours out there altogether. Not all of it was imaged this time. As you can see, I only got a little over 3 hours. But there were other things had to be done. There had to be calibration frames taken. I had a situation where the meridian flip had to be done, where I had to change the telescope from one side of the sky to the other. There was one when I had an airplane went right through the field. I was taking my red image, which totally ruined 40 minutes of data there, which I had to retake. And I had one computer issue which kind of bugged me for a little bit, but that was cleared up pretty quickly. So anyway, guys, that's what I got. We'll be talking to you soon. And unfortunately, we're probably at the end of gold prospecting for the season. The first snowfall has probably already fallen up in Vermont. Here in northwestern Connecticut, we may just catch a little dusting later on tonight. But the cold weather's coming. And in fact, it'll get so cold that I won't even be able to do much of this stuff because it's just too darn cold. And when you spend hours out there, it's not pleasant.